All right, so I've been debating flat Earth now for probably about a month online, just kind of as a hobby. And I was talking to a guy in Hawaii this morning who thinks that the Terminator line on the moon does not agree with the globe model in some way. I don't really understand the claim, but I decided to make a video to try and explain how it works. I got my helper here. He's going to help me with the lights. Just a minute, right? You're going to help me? Okay. I've got a moon model. So this is my moon. It's hanging from the ceiling by a string. And this is my sun, which is the same lamp that I used earlier for the rainbow experiment. It's got a board blocking the extra light because it was kind of distracting in the video. But it works really well. It's a daylight bulb. It's really bright. And hey, look, there's Nibiru off to the side. Nibiru, I think they call it Nibiru. No, it's just glare on the lens. And the glare, by the way, is another thing that flat earthers talk a lot about. Makes the sun grow bigger. Look, the sun's bigger now. And then, oh wait, no, it's not. Yeah, I don't understand that part. But anyway, we're going to start from full moon. Austin, you ready? All right, let's see if I can get all the terminology right. There's a lot of terminology with the moon and hard to keep track of. All right, hit the lights. All right, so here's our moon. I don't have a moving moon, so I'm going to move. And the moon is going to stay still, but let's just pretend that the moon is moving and I'm staying still. And in reality, the way this works is the moon's going around the Earth, but the Earth is spinning at the same time. So the moon moves through the sky. See if I can get this right. So the moon moves through the sky rises in the east and sets in the west just like the sun, because the Earth is turning. So the Earth's turning like this. The moon sets, and then we go to daytime. And I'm not going to do this every time, but so the Earth is turning, and every day the moon ends up a little bit further to the east. So daytime, we turn around, we get to nighttime. So that's how the moon moves through the sky, right? So every day it's a little bit further to the east. If you hold your fist out at arm's length, the moon moves to the east about the width of your fist every day, and completes an orbit around the Earth every 30 days. So now we have what we call the fourth quarter moon. I think I got that right, fourth quarter moon. And then as the Earth keeps going around, keep in mind it's spinning, but I'm not going to spin. I'm just going to show how it looks every day at the same time. This is a waning crescent moon. And then as we get toward new moon, a lot of people don't realize you can't see the new moon because it's in the middle of the day. So the new moon is really close to the sun. That might be about the smallest you could ever see the new moon, the crescent, because it's in the sky at the same time as the sun, maybe at sunrise or sunset. And then when you're at the new moon, this is when the eclipse actually happens, which we can actually have an eclipse here if we want. There's an eclipse. But in reality, the eclipse doesn't happen every new moon, right? It's pretty rare because the orbit of the moon is tilted from the Earth. So it doesn't line up every time. But there's the new moon and an eclipse. And then as we go into the lunar cycle more, this is a waxing crescent. And then first quarter and waxing gibbous and full moon again. And then this is, if it was lined up exactly right, you would have a lunar eclipse where my head is blocking it. And there's my wife probably, she's going to tell me that I have to stop researching flat Earth and go back to my job. All right, Austin, hit the lights. Thanks for watching.